So our first question is from a 2017 prelim exam paper. So we have question 2. Now question 2 states a 120-gram tennis ball is dropped from the roof of a building. It bounces off a balcony 12 meters below and finally falls to the ground. The diagram below shows the flight of the ball. Ignore all the effects of friction as well as the horizontal motion of the ball. So as you can see by that diagram, we've got a balcony that's on level 1 if we assume the road or the ground to be level 0. So we've got a balcony on level 1. Now this ball is dropped. Keep in mind that when an object is dropped, it has an initial velocity of 0. If an object is projected or thrown, it has some positive or negative velocity. But if it is dropped, it is always going to be a velocity of 0. So this object is dropped. It is then displaced 12 meters downwards until it hits the balcony. Once it hits the balcony, it rebounds, reaches a new maximum height, and then falls to the ground. Now, something important when reading this particular question is that the unit of measurement of mass is incorrect. We know that when we are dealing with physics, our mass needs to be in kgs, and when we are dealing with chemistry, our mass needs to be in grams. So the correct unit of measurement for this is 0.12 kgs. If you are not sure on how we obtained 0.12 kgs, it is from dividing by 1,000. If you want to convert from grams to kgs, you divide by 1,000. If you want to convert from kgs to grams, you multiply by 1,000. Now, let us read that statement once more. A 120-gram tennis ball is dropped. So that is the second important statement. Dropped, meaning that it has an initial velocity of 0. From the top of a building, it bounces off a balcony 12 meters below and finally falls to the ground. So let us have a look at our first question. So we have question 2.1. Calculate the velocity with which the tennis ball strikes the balcony. So we need to calculate the velocity when this tennis ball hits the balcony. So a few important things that we need to do before we can get to the calculation part is we need to identify which direction we are taking as positive. Now that choice is completely up to you. If I take upwards as positive, it does not mean that it is compulsory, nor are you obligated to take upwards as positive. So for all the calculations that we are going to do today, unless otherwise stated, I'm going to assume upwards as positive. If you prefer to take downwards as positive, whatever values I have, you are going to change the sign. So if I have a positive value and you are taking downwards as positive, you make it negative. Or if I have a negative value and you are taking downwards as positive, make your value positive. So whatever value or whatever sign I have, make your sign the opposite if you are taking downwards as positive. So we have question 2.1. Now, question 2.1 needs us to calculate the velocity with which this object hits the balcony. So before we do that, let us sketch this so we can get an idea of what's going on. If you've noticed from the previous class, I prefer to sketch what I'm doing. It makes life slightly easier for me, or it makes it easier to understand. So this is our balcony. Now we've got this object that was dropped. Now when this object is dropped, it has an initial velocity of 0. So we can make a note of that. There is an initial velocity of 0. This object then goes down, 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 and hits our balcony. So I'm going to stop my sketch there. I'm not going to continue with the rebound because that is all we need for now. We only need from the time it is released or dropped until the time it hits the balcony, because this is the velocity that we are looking for. We are looking for the velocity with which this object hits the balcony. Now, because I've taken positive or rather because I've taken upwards as positive, my ball is going downwards. My final velocity is in a downward direction, which means that I need to end up with a negative value. So we've indicated what is our initial velocity. Let us indicate what other values we know. So our acceleration is going to be negative 9,8. Why? Because the acceleration always acts downwards and I've taken upwards as positive. So because acceleration is acting downwards, it's going to be a negative value. Next, we have displacement. Now, displacement is going to be negative 12 meters because the object was displaced a total of 12 meters from the top of the building until the balcony. Now, how do we know whether it's going to be negative or positive? So all you need to do is draw an arrow in the direction of your displacement. This is my displacement vector. So from the top of the building until the balcony. As you can see, that arrow is in a downwards direction. So it's going to be negative. Why? Everything going down is negative. Everything going up is positive. Alternatively, what you can do is you can do a slight calculation on the side of your page. So if we want to calculate displacement, it's going to be the final position minus the initial position. Now for this, we need a reference point. So because we don't know the height of the balcony above the ground, what I'm going to assume for this calculation is I'm going to assume that to be my ground level, or you can assume it to be your 0 reference point. So you assume this to be height of 0. So our object was initially at the top of the building, which means it had an initial height of 12 meters above the 0 reference frame. Finally, it hit the balcony, which is at a height of 0 meters. It's on the reference frame. So if we want to calculate, all we need to do is substitute the final height, which is 0, minus the initial height, which is 12. And that gives us negative 12 meters. That is how we end up with that negative 12 value. So let us move on to calculating the velocity. Now that we have our values that we are going to use, let us try to identify what formula we can use. So the 4 formulas that we know of when dealing with vertical projectile motion are Vf equals Vi plus A delta T. Vf squared equals Vi squared plus 2A delta Y. We've got delta Y equals Vi delta T plus 1 over 2 A delta T squared. And finally, we have delta Y equals a half into Vi plus Vf times delta T. Now we need to identify out of the 4 formulas, which is the best for us to use in order to calculate the final velocity. So step 1, when eliminating formulas, when finding out which is the best formula to use, I would recommend starting off with what you are calculating for. So because you are calculating for final velocity, eliminate any formula that does not have final velocity in it. So if we look at formula 1 and 2 and 4, they have final velocity in them. It is only formula 3 that does not have final velocity in it. So how can we calculate for final velocity if it is not within the formula? So we are now eliminating formula 3. Let us have a look at formula 1, 2, and 4. What can we do to eliminate these in order to remain with a single formula? Sometimes you can have 2 formulas that can work, or 3. That's completely up to you and which you choose. But let us eliminate until the point whereby we can say, okay, these are the formulas that we can choose from, or these are the formulas that we can use. So let's start with formula number 1. We need to calculate VF. So that is good. We have VI. That is good. We have A, but we do not have time. If you look at the variables that we have, these are the variables that are known. We do not have time. So any formula that has time in it, we can get rid of, or we can eliminate. So that means formula 1, which has time in it, and formula 4, which has time in it. So the only formula that we can now use is formula 2. So let us make use of formula 2 in order to find the final velocity, or the velocity with which the object hits the balcony. So we are now going to substitute for VF, which is still VF as it is unknown. Next, we'll substitute for VI, which is 0. So we have 0 squared. Next, we can substitute for our value of A, which is negative 9,8. And finally, our displacement value of negative 12. From here, we can put the entire right-hand side into our calculator, and that will give us a value of 235.2. From here, we can square root both sides. So once we square root our right-hand side, that should give us a value of 15.34. But keep in mind, because we've square rooted, it gives us a positive and a negative value. So we end up with positive and negative 15.34. So we now need to identify which is the correct value to take. Are we going to take the positive value, or are we going to take the negative value? Now, the reason that this is important is because it will affect future calculations. If you are going to use the velocity with which the object strikes the balcony in future calculations, and you take the wrong sign when substituting, your calculations are going to be incorrect. So take the correct sign whenever you square root. Don't just automatically assume it to be a positive value because your calculator does not have a negative. So let's identify, are we taking positive 15 or negative 15? Now, as I mentioned previously when we first started with this question, our object is moving in a downwards direction, which means our velocity just before the object hits the balcony is downwards. And we are taking upwards as positive, which means everything moving downwards is negative. Therefore, our final velocity is going to be negative 15,34 meters per second. And that is it. That is all we needed to do to calculate the velocity with which the object hits the balcony. Now, something important to take note of. If you did not identify that this is negative 12, let's say you assumed your displacement to be positive 12, and you substituted a positive 12 into this formula, you would have ended up with negative 235.2. Once you try to square root a negative, you would have ended up with an error. That is an indication that you've made an error or that your signs are incorrect. So if you have no idea, or if you are not sure where the error is, just go back and see or change one of your signs. Or if you don't want to change one of your signs, just make this negative a positive, just so that you can continue with the question if you have no idea where your error is. That way you can at least get some of the marks. But I would recommend taking a step back before you write your exam, going and learning how to calculate or how to find the displacement within vertical projectile motion. It will make your calculations a lot easier, and it will remove your doubt whenever you are doing questions. So let us move on to the next one. So we've got question 2.2. The energy transformed to other forms when the ball strikes the balcony is 2 joules. So when this object hits the balcony, 2 joules of energy is dissipated into the surroundings. That is why the object does not reach the original height from which it was thrown, or from which it was dropped, rather. This is something that you've covered in momentum. So another way of thinking about it, after the object was dropped and hit the balcony, it lost some of its energy. That is why it was unable to reach its original height. Let's say, for example, you're climbing up the side of the building and you fall and you hurt your leg. You're not going to be able to climb as high as you previously did. Why? Because you have an injury. So it's kind of a similar situation with this. The object was dropped, hit the balcony, and lost 2 joules. So it was injured in a sense. That is why it was unable to reach the exact same height from which it was dropped. You'll see the same situation in real life. If you drop an object from an elevated position or from a height, the object is each bounce or each new maximum height is going to be lower than the previous one. So we need to calculate the energy just before the bounce. So whenever we are calculating kinetic energy, we need mass and we need velocity. So what is nice about this is that we've already calculated velocity. Something that's not nice about this is that if you calculated an incorrect velocity, or if you did not correctly calculate for question 2.1, you would have also got question 2.2 incorrect. So question 2.2, we need to calculate the kinetic energy of this object. We know that our formula for calculating kinetic energy is 1/2 mass times velocity squared. Now keep in mind we're using the velocity just before the ball hits the balcony. So we're going to substitute the mass, which was 120 grams, which we've already converted to 0.12. Next, we can substitute the velocity just before the object hits the balcony, and that is -15.34. Don't forget that it is squared. So from here, we have our kinetic energy. Once we put this into our calculator as 14.12. And don't forget your unit of measurement is joules. Actually 12, not 21. Sorry about that. So that is going to be 14.12 joules. That is the kinetic energy of the ball just before it hits the balcony. So what we are now going to do is take a small break for me to go through the chats, as I've noticed there is a question, so allow me a moment. Okay, so there's a student that's asking, why is delta y -12? So the reason that delta y is -12 is because displacement is a vector quantity, which means that it has a positive or negative, or that it has direction. So as we've stated, upwards as positive, whatever vectors are moving downwards will be negative. So because displacement, or because this object was displaced in a downwards direction, that is why displacement is negative. If you struggle to understand the concept of vectors, you can use a calculation. So the student that asked that question, you can refer to the calculation that I've just highlighted. That shows why displacement is negative 12 meters. So let us move on to question 2.2.2. So we've got question 2.2.2 that states how high the ball rises above the balcony after the bounce. So we need to calculate how high does the object rise above the balcony. That statement is important. We're not calculating above the ground. We are calculating above the balcony. So we are still going to use the balcony as our zero height or zero reference point. So we need to calculate how high above the balcony does the object reach. So we're calculating the maximum height. We're calculating the height of this object. What I've highlighted or circled in red, we're calculating that height. So let us do a quick sketch, and then we can write down the values that are known so we can then solve the question. So this object was dropped. There's our balcony. It was dropped. Hits the balcony. And then rebounds after losing 2 joules of energy. So I'm going to stop my sketch over there because that is the last point that we need, or that is the point that we need to calculate. So let's put in a few values. So we know that the initial velocity, or let us just call it V in case this is not our initial point that we are going to use. So we know that the velocity with which the object was dropped is 0. We then know that the object hits the balcony with a velocity that is negative 15,34. Once it hits the balcony, it loses 2 joules of energy. After it loses that 2 joules of energy, it then rebounds off the balcony with an unknown velocity and reaches maximum height. We know that at maximum height, our velocity is going to be 0. So I'm going to take my initial point as when the object rebounds off the balcony. That is going to be my initial in this particular case. So when it rebounds with an unknown velocity. My final, I'm going to take it as the maximum height. So those are my initials and finals for this particular scenario. Now, before we can actually start to calculate or to use our initial and final, you need to understand that the initial velocity, the velocity with which the object rebounds, is unknown. We do not know the velocity with which the object leaves the balcony. But what we do know is that the object loses 2 joules of energy once it hits the balcony. So let's think of it like this. If you go into the shop with 14 rand and 12 cents and you spend 2 rand, you're going to come out of the shop with how much of money? That's the understanding or the approach that you need to take with this particular question. So the ball hit the balcony with 14.12 joules of energy. It then lost 2 joules of energy. So how much of energy did it leave the balcony with? That energy that it left the balcony with will assist us in calculating the velocity with which it left the balcony. How do we make that assumption, or why can we now say that energy is helping us to calculate velocity? It is because velocity is a component within our energy formula. So if we have energy and mass, we can calculate velocity. So first step, we need to identify how much of energy the ball rebounded with, or how much of energy the ball left the balcony with. So before the balcony, it had 14,12 joules of energy. Now this was before the balcony, or let's say when it hits the balcony. We then know that 2 joules of energy is lost. Think of it as delta K. The change in energy was 2 joules. So 2 joules of energy was lost. How much of energy is left behind? So let's move back to the money example that I mentioned previously. If you go into the shop with 14 Rand and 12 cents and you lose or you drop or you spend 2 Rand, how much of money do you leave the shop with? All you do is take the amount of money you entered, subtract what you lost, and that will be the amount of money you leave the shop with. So we are going to do the exact same thing with this. So we're going to take the amount of money we initially had, which is 14,12, subtract what we lost, which is 2 joules, and that then gives us the amount of energy that is left behind. So this object leaves the balcony with an energy of 12.12 joules. So this is the rebound energy.
Hello.
Yes, you have do you have a question?
Oh yeah, I do have a question. I just want to ask, where does the 2 come from? The 2 joules.
The 2 comes from the question. So let me go back to the question to allow you to see. So do you see statement 2.2? I've highlighted it as well. So it states that the energy transformed to other forms when the ball strikes the balcony is 2 joules. Always remember that whenever an object hits another object, or whenever objects come into contact, there is energy dissipation. Energy is dissipated in the form of heat, light, sound, deformation, and other things. Think of it as if 2 cars meet up in an accident, or if a car collides into if a car smashes into a wall, what happens to that car? There's deformation because the front end of the car is smashed. There's light. Why? Those sparks, even though you can't see it, it's such a split second where those sparks fly off when it hits, because it's metal on another object scraping. So there's light. There's also sound. You hear that bang when the car collides with the wall. So energy is dissipated in those forms. Keep in mind what you learned in grade 10, that energy is neither created nor destroyed. It is just changed from one form to another. That was your law of conservation of energy. So that's what you need to use to, or that's the knowledge that you need to apply to this particular question. You need to understand that energy is being lost when the ball collides with the balcony. So you go into the shop with 14 Rand, you lose 2 Rand, how much do you come out with? Think of it like that. So this ball hit the object or hit the balcony with 14.12 joules. It lost 2 joules and it rebounded with how much of energy? Just -2 or 2 lower than what it entered with. Okay.
Yeah, thanks.
Perfect. Then the student that left a message in the chat box, I'm so sorry, but I cannot pronounce your name. Lehlohonono. You mentioned, please repeat for me. What do you what part do you want me to repeat so I can do that? And then the student that's asking, am I writing with the mouse? No, I'm not writing with the mouse. I'm writing with the pen. Okay, so please repeat for me question 2.2.2. Okay, so question 2.2.2 states how high, calculate how high the ball rises above the balcony after the bounce. So after this ball bounces, which means after it hits the balcony and rebounds. So it's dropped, it's going in a downwards direction, it hits the balcony and then moves in an upwards direction to a new or to a maximum height. So our question wants to know how high above the balcony did the ball reach? So where I have F maximum height, we need to calculate how high above the balcony is that. So keep in mind that we know that the object hits the balcony with 14.12 joules of energy. In addition to that, it has a velocity of negative 15.34. That is what is known. What is not known is the velocity with which the object rebounds. Keep in mind, rebound just means to change direction or to bounce, okay? So we do not know the velocity with which this object leaves the balcony. But we have a way of calculating that. Always remember that the velocity with which something collides is not the same velocity with which it rebounds. There's always a change in velocity due to energy dissipation. So always keep that in mind. Don't just automatically assume that because the ball hit the ground with 10 joules of energy or 10 meters per second, it's going to leave the ground or rebound with the exact same velocity or the exact same energy unless otherwise stated. Keep that in mind. So we now need to calculate the velocity with which the object leaves the ground. So we can use, not ground, leaves the balcony, so that we can use one of our 4 equations of motion to calculate displacement, because we have we have final velocity, which is 0 meters per second. That is the maximum height velocity. Once we calculate the rebound velocity, that will be our initial velocity. We have our value of A, so we can then calculate displacement. So let us now calculate the velocity with which this object rebounds. That is going to be our initial velocity for our calculation. So we now know the energy with which this object rebounds. So let us use our kinetic energy formula. We have EK equals a half mass V squared. So we substitute in place of our kinetic energy, the energy with which the object leaves the balcony, which is 12 joules, is equal to a half times the mass of 0.12. Keep in mind that the mass was initially given to us in the very first statement of our question, times velocity squared. But we do not know that value or that velocity. That is what we are trying to calculate. So on our right side, we can multiply a half times 0.12, and we will end up with 0.06. So we have 12,12 equals 0,06 V squared. Because I know that this is my initial velocity, I'm going to use it as my initial velocity. I'm going to put a little subscript I, so we remember. Now from here, I'm going to divide both sides by 0.06. So 12.12 divided by 0.06. and that gives me 202 equals VI squared. From there, I can square root both sides, and I then finally end up with a velocity of 14.21. So my initial velocity in this particular case is 14,21 meters per second. Please do not confuse the kinetic energy and the velocity. I know they have quite similar values, 14.12 and 14.21. It's not the same thing. Energy and velocity are different. Please keep that in mind. So now that we've identified, or now that we've calculated the velocity with which this object rebounds, let us just make a note of that. So in brackets, I'm just going to put 14,21 so that we know that is the velocity with which this object rebounds, just in case we need to come back to this drawing at a later stage. At least we have the information on there, so it makes it easier to find. So let us go back and read our question once more. So our question 2.2.2 states, calculate how high is displacement, how long is time. So keep that in mind, it's important. So calculate how high, meaning calculate the displacement. So calculate how high the ball rises above the balcony after the bounce. So we need to calculate displacement. What formulas out of our 4 equations of motion can we use to calculate displacement? Keeping in mind that we have initial velocity, which is the rebound velocity, and we have final velocity, which is the velocity at maximum height, and we have acceleration of negative 9.8. So let's make a list of our formulas. I'm going to exclude all the formulas that have time in them. Why? Because we do not have time. So this formula has time. I'm going to exclude it. Let's see our next formula. I'm actually not going to write any more formulas. I think this is the one that we are going to use. So we are looking, or we have VF, we have VI, we have A, and we are looking for acceleration. So this is the formula that we are now going to make use of. So before I continue, I have seen that there is a question in the chat. Just give me a moment to address it. Okay, so if we were not told that 2 joules of energy was lost, can we assume that the velocity of the ball when it reaches the balcony is the velocity when it rebounds? I would suggest don't assume it unless otherwise stated. So if they state that the velocity with which the ball hits the ground is the velocity with which it leaves, then you can assume that and proceed. But if they do not state, don't just automatically assume, because keep in mind that energy dissipation is a real thing. So if you look at the real world, energy dissipation is everywhere. So always assume that energy dissipation is taking place. So something important, they won't leave out important information or not give you a way to calculate something. So if you see that there's no way for you to calculate something or to identify a specific value, in most cases, you're not going to use it. So find a different way to calculate. It's most likely that your approach is not the one that they wanted you to take. So the nice thing about grade 12 physics is that they give you everything that you need. They won't give you things that you're not going to use. So yeah, Zainab, unless they state that the velocity with which it hits the balcony is the velocity with which it leaves, then don't just automatically assume. Something important to take note of is that there's a difference. So let's say this is our ground. The velocity with which this object hits the ground is not, so let's call this V1. So the velocity with which the ball hits the ground will not be the same as the velocity with which it leaves the ground. Because it is colliding, there's a collision taking place. However, the object was thrown upwards, reached a maximum height, and then fell down. V1 is equal to V2, but the signs are not the same. So the magnitude of V1 is the same as V2. Why? Because when the object reached a maximum height, it did not collide with anything. It's in the air. There was no collision that took place. That is how we are able to state that the velocity just before maximum height will be the same just after. That is how we're able to say that the velocity here, let's call it V3, is the same as the velocity here, let's call it V4. If an object is projected upwards like this, and then hits the ground, let's call this V1, V2, V3. So V1 is the same as V3. Why? Because it's at the same level, at the same height. Velocities at equal heights will be the same because there's no collision that took place. The ball just reached a maximum height and changed directions. It didn't collide with anything. So there was no loss of energy. Okay, so keep that in mind. The only difference is the signs. So if you take positive up, on the left side, the values will be positive. On the right side, it will be negative. That's the only difference that you need to keep in mind. Okay, just give me a second. I see there's still a few other questions. If we were not given the energy 2 joules, where we were going to use the velocity, if you were not told that there was 2 joules of energy dissipation, we would need to use a different method to calculate for this question, okay? If they require you to use that rebound velocity, they will always give you some indication. So always remember this. If they do not tell you the amount of energy dissipated after the ball hits the ground, or they don't give you a contact time that can allow you to calculate velocity, keep in mind, you can calculate rebound velocity using one of 2 methods, using energy dissipation or contact time. There was a question that we did last week, Sunday, that had contact time in it. I believe the contact time was 0.2 seconds. So the object hit the ground, was in contact with the ground for 0.2 seconds. That contact time allowed us to calculate the rebound velocity. So always remember, there will be some sort of information that will assist you in calculating for that specific quantity. If there's no information relating to it, don't use that method. Okay, so I'll repeat once more. If they don't give you the velocity, or if they don't give you the energy dissipation, or if they don't give you contact time, don't use rebound velocity. Identify another way to approach the question, okay? So let us continue. Just give me a second to get rid of this. So let us go back and read our question once more. So our question states, calculate how high the ball rises above the balcony after the bounce. So we've identified that we are going to use our second equation of motion. Let us write down our second equation of motion. That is Vf squared equals Vi squared plus 2a delta y. And we are calculating for delta y, keeping in mind that we have an initial velocity of positive 14.21. It's not going to be negative. Why? Because the ball rebounds, it's moving in an upwards direction. That is why velocity will be positive. If it was moving in a downwards direction, as it was when it hit the balcony, it would be negative. Please keep that in mind. So we have our initial velocity of 14.21. We have a final velocity, which is velocity at maximum height, as 0. In addition to that, we have acceleration. Because I've taken upwards as positive, my acceleration value is going to be negative 9.8. So let's substitute all of this information. My final velocity, which is 0 squared, equals initial, which is 14,21 squared plus 2 times negative 9,8 delta y. The nice thing about using formula 2, or a lot of your formulas within your equations of motion, you can see whether you're in the right direction, or you can see if what you are doing is correct. The algebra will always work out. If you end up with a math error, that's a clear indication that you've made an error somewhere. But if your algebra is flowing, if everything's moving smoothly, I'm not saying it's always, but in most cases, what you're doing is most likely correct. So let us proceed. We now have 14.21 squared. So that is going to give us a value of 201,9241. We still have 0. Now 2 times negative 9,8. That is going to give us negative 19.6 delta y. From here, you can move negative 19.6 delta y to the other side, giving us positive 19,6 delta y equals 201,9241. From here, all we now need to do is divide both sides by 19.6. So 201.9241 divided by 19.6, and that gives us 10.3. Don't forget that is meters, okay? Why did we end up with a positive value? Why did we not end up with a negative value? So let's go back to our graph and explain that. So if we look at our graph, previously we had a negative 12 meter displacement. Why was that? Was because our object was displaced a total of 12 meters from the top to the bottom. Something to take note, when we refer to displacement, or when we say the object was displaced, think of it like movement. So when we say the object was displaced 12 meters, we mean that the object changed positions. It moved 12 meters. A nice way to think about it is those that watch Naruto. If you think about the substitution jutsu, it's kind of like displacement. You change positions over a distance. So think about it like this. The object from that initial height used substitution jutsu and then moved to the balcony. Its position changed. So think about it like this. The object was displaced 12 meters. Another way of saying that is that the object changed positions to 12 meters away from the original position. So our object was displaced or moved in a downwards direction. That is why it was negative initially. It then rebounded. So it went from the balcony to your maximum height. So let's ask ourselves, if we go from the balcony to the maximum height, is our displacement, or are we moving in an upwards direction, or are we moving in a downwards direction? As you can see, to go from balcony to maximum height, that is an upwards direction. That is why our displacement ended up being positive. So always keep that in mind. The use of the word displaced just refers to a change in position. If you are changing your position from top to bottom, it's going to be negative. If you change your position from bottom to top, it's going to be positive. That is only on the condition that you took upwards as positive. So keep that in mind. Another indication that we can see that our answer is correct is because our maximum height, as you can see from the graph, is lower than the height at which the object was dropped. Keep in mind that this height, the top of the building, is 12 meters. And as you can see, this maximum height is less than 12 meters. Look at our answer, 10.3 is less than 12. So that is another indication that what we've done is correct. So all we needed to do was understand that when the object hit the balcony, it lost 2 joules, which means that the energy with which it hit the balcony is not the same energy with which it left the balcony. What does that mean in terms of velocity? Keep in mind that velocity and energy are linked. They are directly proportional to one another. So energy and velocity are directly proportional to one another. So if our energy decreased, it means that our velocity would have also changed or decreased. If you look at it, ignore the signs, 15.34 and 14.21, there's a decrease in value or decrease in magnitude, right? So you can see that just by understanding that energy is linked to velocity, you were then already able to say, okay, I know that my velocity is going to be less. If you ended up with like 20 for your velocity, that would have been a clear indication that you were incorrect. So always try to understand what's going on. That will allow you to say, okay, I'm confident in what I did. You can leave your exam with a smile on your face and move on with life. Okay, so the most important thing is to understand. Understand that the object hit the balcony and then lost energy. So the velocity with which it hit the balcony is not the same velocity with which it left the balcony. Why? Because there was a loss in energy. Once we were able to calculate the velocity with which the object left the balcony, keep in mind that for this particular scenario, I've made leaving the balcony as my initial and maximum height as my final. That is completely up to you depending on the approach that you want to take. Remember, initial and final is flexible. It does not mean that when the object was thrown or dropped vertically downwards, that is the initial eternally. Doesn't mean you're always going to use that as initial. Depending on the scenario or depending on the way in which you approach or calculate the question, your initial and final can be different. My initial and final can be different to yours, but we can end up with the same answer. That is something that is flexible. Okay. Now, once we were able to calculate the velocity with which the object rebounded, we were then able to use our second equation of motion because we had the rebound velocity and the velocity at maximum height, as well as our value of A to calculate displacement or to calculate the height above the balcony of the object. So we now have question 2.3. Question 2.3 states, the ball finally strikes the ground 3.16 seconds after the bounce. That is important. It does not mean that after it was dropped, 3.16 seconds passed and then it hit the ground. That is not what they're stating. They stated after the bounce. So think of the bounce as your starting time and think of the ground as your ending time. So we're going to start our stopwatch at the moment it hits or leaves the ground. So at the moment it leaves the ground, start your stopwatch. 3.16 seconds pass and then the object hits the ground. Now, we need to calculate the height of the balcony. So we are going to use displacement to calculate the height of the balcony. Something that you should have noticed in last week's session and this week's session. Displacement is something that is extremely important and something that can be slightly confusing if you don't understand what's going on. So I would advise, before you do anything else, go and learn how to use displacement. Then move on to past paper questions. So let us do a quick sketch of what's going on, and then we will try to solve the question. So this is question 2.3. Now we've got our building, we've got the ground, and we have the balcony. Let's make the balcony a bit higher. So this is our balcony. Now we've got our object that was dropped, but I'm not going to draw the initial part. I'm not going to draw from the time it dropped till it hit the balcony. I'm going to start, or I'm going to sketch the motion of the 3.16 seconds only. That means from the time it rebounds, that's all I'm going to sketch to avoid confusion. So it left the balcony, went up, 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 reached a maximum height, and then down, 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 and hits the ground. That is all that I am going to sketch. Now, in order for us to calculate the height of the balcony, what is going to become important is understanding and using displacement. So I'm going to explain that in a moment. Let us just put in some values. So we know at maximum height, actually before we even get to our values, let's explain displacement. Let me explain how I'm going to use displacement to calculate the height above the balcony. So I'm going to do that by labeling. We're going to call this 1, 2, and 3. So I'm going to refer to those points when explaining. Point number 1, point number 2, and point number 3. So from point number 1 to point number 2, our displacement is positive. Why? Because our object moved from a lower height to a higher height, or it moved in an upwards direction. So our displacement is going up. So I'm going to use a vector to explain that. So we have this vector. This vector goes from 1 to 2. Next, from 2 to 3. So once it reaches maximum height, it then hits the ground. So from 2 to 3. So if you go from a higher level to a lower level, are you going up or are you going down? Think about it logically. To go from the top to the bottom, you're going in a downwards direction. So I'm now going to draw this vector going down. So the vector goes from 2 until 3. Now, what is left over, or what is the resultant vector? That is going to be the height of the balcony, your resultant vector. So let's explain that using actual values. So from 1 to 2, we calculated that it is 10,3 meters. We then know that this vector that is going from 2 to 3 is going to be the 10,3 meters plus some unknown height. Because if you compare the two, 1 to 2 is shorter than 2 to 3. But 2 to 3 has that 10 meter. It has the original, or it has the 1, 2 vector in it. Just give me a moment, please. Sorry about that. Now, what we are saying is we are going to use these vectors. So I'll explain using vectors, and then I'll explain using a formula next, okay? So depending on which you prefer to use, whether it's vectors or whether it's formulas, both explanations will be covered. So if you look at both vectors, let's think of this as forces, because that's something we are used to, right? So let's call this force 1, 2, and let's call this force 2, 3. So if we want to find the resultant force, so if we add up the forces F12 plus F23, we're adding up these forces in order for us to get the resultant force. Let's have a look at their directions. We're taking upwards as positive and downwards as negative, which means this is going to be negative F23. So let's say for whatever reason, we're using an example. This is not the value. Let's just say for whatever reason, we calculated the vector of F23 as, let's say, 20 meters. So that is going to be negative 20 meters. So if we add them up, we'll add up 10,3 plus the negative 20, and that will then give us negative 9, which will be negative 8,7. Let me just double check that math. So 10.3 minus 20, it's 9.7, not 8, sorry. So that resultant vector, or that resultant force, will give us negative 9.7. So those are forces, we are used to that, which means the leftover piece, so if we draw this across, this matches this part. So this cancels this, and we are only left with this piece. That piece is negative 9.8. Now, use that understanding of forces, and let us calculate the displacements. So I'm still going to use that as 20 on the right, okay? Think of it as the example. So if we say that the vector on the left, let's call it h1, is 10,3 meters, and the vector on the right, call it h2, is 20 meters, but keep in mind it's going down, so it'll be negative. If we want to calculate the resultant height, or the resultant vector, or the resultant displacement, all we need to do is add them up. So we take h1 plus h2, and that'll give us h net, or h resultant. So we're going to take 10,3 plus negative 20, and it will give us negative 9,7. What that means is that the balcony is 9,7 meters above the ground. That's not the actual value to the question. This is just an example, okay? Let's look at it in a different way if you don't understand that. Let's look at it in terms of cancellation. So I'm going to start erasing pieces. So if we look at the left, the vector from 1 to 2. So if we draw a line from left to right, do you see that it intersects at that point? If you draw another line from left to right, do you see that it's going to intersect at this point? Which means that if we have an equal magnitude in opposite directions, it cancels out. We know that from math. Negative 2 plus 2, it's the same magnitude, different directions. It cancels out, which means that this part, just give me a second to erase. It means that this part cancels out this part. And if you look, we are only left with the height above the ground of the balcony. We are left with the balcony's height. That is our resultant. That is what we needed to understand, that this cancels this, and we are left with the height of the balcony. So before I proceed, is there anyone that does not understand how we are going to use displacement to calculate for the height of the balcony? If you don't, if there's still something or concept that you are struggling with, please speak up now so that we can attend to it before we proceed. Alea, you have your hand up. What's your question?
I don't understand. Please repeat.
I'm unable to hear you. Please, can you repeat yourself a bit louder?
I don't understand. Can you please repeat?
Okay, so let me explain using an equation, maybe. Maybe that'll be a better approach to take as well. I actually did say that I would do the equation one as well. I forgot. Let's think of this in terms of positions, right? So let's say we had this guy that's standing over here. And then for some reason, he jumped or he used a substitution jutsu and he ended up at 0.3, right? So what is the change in his position? He ended up from 0.1 to 0.3. There is a change in position. So let us calculate that change in position. So in order to do that, let us put in some values. We know this is a height above the balcony of 10,3 meters. Now, we need to calculate the balcony's height. So let us say that this is h. Let us assign the height of the balcony as h, which then means that the height above the ground of 0.2 is now going to be 10,3 plus h. Okay, so let us calculate this guy's displacement. We're going to take the final, which is height at 3, minus the initial, which is height at 1. So what is our height above the ground at 0.3? It's 0. Minus, what is our height above the ground at 0.1? It's h. So as you can see, we will end up with negative h. And whenever we deal with height, remember height is not the same as displacement, right? So when we're talking about height, we will ignore the negative sign. So we will therefore say height equals whatever value that this is, which is h. Can you see that all we did was calculate or show that we're finding h? All I did with this equation was show you that when you calculate the change in this person's position, you are ending up with h. And what is h? H is the height of the balcony above the ground. Let's do it in a different way so you can see once again that when you calculate displacement of this object or of this person, all you are technically doing is calculating the height above the ground of the balcony. Even if you don't know what is the height at maximum, let's say, for example, in this particular question, we didn't know what is maximum height. So let us call the height of the balcony, let us call that A. That value is A, okay? We're associating height above the ground of the balcony as A. So if we want to calculate the displacement of this person, it's going to be h at 0.3 minus h at 0.1, final minus initial. Now, our height above the ground at 0.3 is 0, minus our height above the ground at 0.1, which is A. When you calculate that, you end up with negative A. So once again, it doesn't matter what you use to associate those values. In the end, you can clearly see that when you calculate the displacement of this object, you are technically calculating the height above the ground of the balcony. Why? Because this part cancels out this part, because they are equal vectors in opposite directions. They have the same magnitude, but they have different directions. One is positive, one is negative of the same value. So they cancel out, and your resultant or your leftover is this part here, which is the height above the balcony. So that is it. Whatever way you choose to understand, whether it's with vectors or it's with a formula, you need to understand that displacement can cancel one another out in certain areas. Okay. So let us now proceed with this question. So before we proceed, let us just go and read what the question was again. So we have question 2.3. The ball finally strikes the ground 3.16 seconds after the bounce. So I'm going to label initial and final. I'm going to call this initial, and I'm going to call this final. So the time to go from my initial point to my final point is 3.16 seconds. Keep that in mind. The time to go from the bounce to the ground is 3.16 seconds. So let's continue to read our question. The ball finally strikes the ground 3.16 seconds after the bounce. Calculate the height of the balcony. So let us see what values are known. We know the velocity with which the ball leaves the balcony. We previously calculated it in question 2.2.2. So that is my initial velocity or my rebound velocity. My final velocity, I do not know what is the velocity with which the ball hits the ground. I don't know that velocity, so I'm going to leave it out. Let's see, what else do we know? So let us just make a note of what we know. We know initial velocity, which was 14.21, I believe. Let us just double check. Yep, 14.21. So we know the velocity with which it rebounds, or the initial velocity. Next, we have acceleration, which is negative 9.8. And we have time, which is 3.16. So let us identify which formula we are now going to use in order to calculate displacement, which will be the height above the balcony. So we've got our first formula, which is VF equals VI plus 2A. Actually, it was plus A, not 2A. So plus A delta T. VF squared equals VI squared plus 2A delta Y. And V, or rather, delta Y equals VI delta T plus 1 over 2A delta T squared. And lastly, delta Y is equal to a half into VI plus VF delta T. So step number one, just as we did in the very first question, 2.1, we're going to eliminate based on what value we do not have. So we do not have final velocity. So any equation that has final velocity in it, we're going to eliminate. So equation 1, there's final velocity, that's out. Equation 2, there's final velocity, that's out. Equation 4, there's final velocity, so that is out. So the only equation that we can now use is equation 3. So we are calculating for displacement. We have initial velocity, we have time, and we have the value of A. So we can now safely use equation 3 to calculate our height of the balcony above the ground. So equation 3 is displacement is equal to V initial delta T plus 1 over 2A delta T squared. Now let us start to substitute. So we do not know the value of delta Y. That is what we are calculating for. So we're going to leave it as delta Y. Next, we have the velocity of our initial, or rather our initial velocity, which is 14.21. We have our time, which is 3.16, plus 1 over 2, our value of A, which is negative 9.8, and our value of time, which is 3.16. Don't forget to square. So I don't want that to mix up with the previous calculation. So let me move it aside a bit. So let us continue. From here, all we now need to do is put the entire right-hand side into our calculator. So we'll put that in, and that will then finally give us a value of negative 4.03. So that is my value of my displacement. So we have delta y equals negative 4,03 meters. But we're not done with the question as yet. Keep in mind the question wanted to know what is the height of the balcony above the ground. When we are referring to height, we just use a magnitude only. We do not use a sign. So we can then say, therefore, the height of the balcony, so we can refer to it as delta y if we want to, or we can replace it with h, is equal to 4,03 meters above the ground. The only reason that we ended up with a negative displacement was because the resultant displacement after this cancelled out this was a vector in the downwards direction. So that is question 2.3. All we needed to do was calculate the height above the ground of the balcony. So, a quick side note, you could have calculated the final velocity if you wanted to, and then used final velocity to use another equation to calculate displacement. I didn't use that approach because I felt it time consuming to have to calculate something I didn't have to. But yeah, if you wanted to, you could have used VF, or rather you could have found VF and then calculated displacement. But yeah, if you didn't want to do that, you could have just straight went away, understood what you were calculating, which is the displacement of the object. The magnitude of that displacement corresponded to the height above the ground of your balcony. Thereafter, you were able to calculate or to determine the height above the ground of your balcony. Always remember, height is scalar. You can't wake up one morning and say, I'm negative 1.5 meters. Height is always scalar, so ignore the negative sign whenever you are dealing with height. Displacement, on the other hand, is a vector, which is not scalar. It has negative or positive, okay? So if there's no other questions, let us proceed to question 2.4. So with question 2.4, that's a graph question. Okay, so we've got question 2.4. Sketch the velocity versus time graph of the ball's entire flight. Show the following points on your sketch. So we need to show the velocity with which the ball hits the balcony. Let's just make notes as we read. So let's see, where's the velocity with which the ball, here's it. The velocity with which the ball hit the balcony is that negative 15.34. So let's make a note next to 0.1. So we need to show this value, this negative 15.34. Let's see, next it states time of flight of the ball to reach the balcony. Mark as T1. So we don't need the actual time value. We're going to mark it as T1, okay? So we need to show the time that it took to go from being dropped till the time to reach the balcony. So on the sketch, let me just show you that. So we need to show the time from this point till the point where it hits the balcony. We need to show this point that I'm highlighting in red, but we do not need the actual time value. For example, we don't need to say it was 2 seconds or 3 seconds or 1 second. We're going to allocate it a value of T1. We're going to use a variable representation, okay? So we're not going to put any value in that place. Let's read bullet point 3. So bullet point 3 states the velocity with which the ball leaves the balcony. So we calculated the velocity with which it leaves the balcony as 14.21 meters per second. So let's make a note of that. Keep in mind it's positive now. Next, we've got bullet point 4, the time the ball reaches maximum height after bouncing off the balcony, mark as T2. So once again, just as bullet point 2, we don't need the actual time that it takes to reach the maximum height. We just need to use a variable representation to mark it. In this case, we're going to mark it as T2. So on our graph, the time that it takes to reach this maximum height, we're going to mark it as T2. So our velocity will be 0, but our time will be T2. So next, we've got our last bullet point, the total time of flight of the ball, mark it as T3. So the total time of flight, that means from the time the ball was released at a height of 12 meters above the balcony till the time that it hits the ground. So at the point whereby it hits the ground, we will then mark that by T3. Keep in mind, we didn't calculate the velocity with which it hit the ground. If you calculated the velocity with which it hit the ground in question 2.3, you could have used it. But because I did not calculate that velocity, I'm going to use a variable representation, meaning I'm going to use negative v in place of that. It's just going to be some negative velocity, okay? I'm not going to use an actual value. So we've now marked what we know from our bullet points. Let us now start to draw this graph, 2.4. So we have question 2.4. We need to draw a velocity versus time graph. Now, before we actually do the graph, I want to make a few notes on the side. What I like to do when drawing my velocity versus time graph is I prefer to put it in a coordinate representation. Because I'm used to dealing with functions and I'm used to my coordinate system, it makes it easier when doing vertical projectile motion graphs to represent certain things as coordinates. So before we do that, let's just sketch our X and Y axis. So let's start with our coordinates. Actually, before we even do that, let's do the exact same thing we did the last time. We'll do a rough sketch and tick off as we progress. So if this is our building, we've got our balcony over here. Now let's draw the motion of our object and then we can tick as we proceed. So initially, our object was dropped. So when it was dropped with a velocity 0. Keep in mind, our coordinates are going to look like this: time, then velocity. Why? Because time is x, velocity is y. So time would be 0 at this point, since it's your initial, and velocity would also be 0 at that point because the object was dropped. So that is our initial. That's our first coordinate. Object falls to the balcony and strikes the balcony. Now, what velocity did it have when it hit the balcony? It had a velocity of negative 15,34. So that's our y coordinate. Our x coordinate, I think we used, or we were told to use T1 or T2 or something. Let us see. We were told the time of the flight of the ball to reach the balcony. Okay, so the time to reach the balcony is going to be denoted by T1. So we're not going to have an actual time value. So my coordinate here is going to be T1 and negative 15.34. From this point, my object rebounds off the balcony and reaches a maximum height. Now let us see if we need to put in a coordinate for when it rebounds. Let us see. The velocity with which the ball leaves the balcony. Okay, so we do need to include the velocity for which the ball leaves the balcony. So that is 14.21. Let's see, do we need to include the time as well? The time the ball reaches the maximum height after bouncing off the balcony is T2. So we do not need to represent a time for when this, well, technically it'll be the same time as T1, so that's fine. We'll just put T1 in its place. Because there was no contact time, it's going to be the same as the previous time, T1. So when it hits the balcony, it's going to be T1 and velocity of 14,21. So that's the third coordinate. Our fourth coordinate is when it reaches maximum height. We were told to represent maximum height by T2 and a velocity of 0. From there, the ball fell down to the ground and hit the ground. We do not know what that velocity is. I think we were told to represent it by T3. Let us double check. Total time of flight, T3. Yeah, that is T3. So we're going to call this T3 and unknown velocity negative V because it's moving in a downwards direction. I don't have that velocity, so I'm just representing it as negative V. Let us identify, are we supposed to indicate the velocity? If we are, that means we'll have to go and calculate it. If we are not told that we do not have to include the velocity with which it strikes the ground, I can leave it as any random or any value such as negative V. So if we read our information, it doesn't state any indication that we need to include the velocity with which it strikes the ground. So these are my coordinates. I'm going to use these coordinates and I'm going to use the sketch as a checklist when I'm plotting my graph. Now, first point on my checklist, that is point 0 and 0. So this is coordinate 1, coordinate 2, coordinate 3, 4, and 5. So coordinate 1 is point 0 and 0. Let us plot that. So the point 0 and 0. This is 0 and 0. We've plotted it. Next, let's move on to the next one. The second coordinate is T1 and negative 15.34. Let us plot that. So all we're now going to do in place of time, we're not going to put an actual numerical value. We're just going to put T1. So we'll make a line and call this T1. And then we'll have negative 15,34. And we'll plot it over here. This will be our point. Now, always remember when the object bounces or when the object changes direction, a new graph is going to form. So in this case, because we have an object bouncing, we're going to have two straight lines, okay? So let's see. Going to now plot this graph. So all we're going to do is connect the 2 points. Okay. Let me use a thicker line. So this will be our graph. So that is the first part. All we did was the initial, which was 0 time and 0 velocity when it was dropped. So we'll make a slight note. Keep in mind that the notes that I make on my graph, you don't have to do that. This is just for you to gain a better understanding. That is when the object was dropped. This is when the object hits the balcony. So, excuse me, those are our 2 points so far. Let's go back to our checklist. Point number 3, it's going to be the exact same time. Because there was no contact time involved, the time of which it hit the balcony will be the same time for which it leaves the balcony, okay? If they stated maybe that there was a 2-second contact time or a 5-second contact time or 0.5-second contact time, we would then need to add that time to the previous time. So if our ball hit the balcony at 5 seconds and there was a 2-second contact time, when the ball leaves the balcony, it will leave at 7 seconds. So it won't be the same time. Keep that in mind. If you don't understand what I mean by that, please refer back to last week's recording. There was a contact time involved in the graph. You can have a look at that. So our next coordinate point, point 3, is T1 and 14.21. So we've already plotted T1. Let us label 14.21. So that is going to be somewhere over here. So we've now plotted that point. This is when it rebounds or when it leaves the balcony. Now, let's go to the next point in our checklist. When it reaches maximum height. When it reaches maximum height, there is a velocity of 0, and our time is indicated by T2. So we've completed this plot. Let us now plot T2 and 0. So after some time, we got to T2. This is point T2. And there was a 0 velocity. So we plot that point. Let us move on to the last and final point. So we now have point 5 when it hits the ground with some unknown velocity. Now keep in mind, because it's hitting the ground, it's moving in a downwards direction. Therefore, it's going to have a negative velocity. Now I don't know what that velocity is because I don't really want to calculate it. But what we can do is just give it some random negative V value. We don't have to put the actual value if you don't want to. If you want to take the initiative and put the actual value, you can, but you don't have to. So let's just put it as negative V. So it's some negative value and it's time T3. So we'll plot it over here. Now what we can do is take our ruler and connect the 3 points. That is going to be our last and final part of our graph. So this was T3, and that's our graph. Keep in mind, this is maximum height. And this is when it hits the ground. Okay, so as mentioned previously, you do not have to include, or you don't need to include the labels. I've just done that so you can see which is which. So that's our graph. From the time it was dropped till it hit the balcony, went up to maximum height, and then dropped or fell down to the ground. That is our graph. There's 2 hands that are up. Tiamo, you had your hand up first. What's your question?
Sir, I wanted to ask if we don't join the 2 lines using a dotted line.
You can if you want to. Yep, that's actually a nice thing to bring up. So you can join the 2 lines to indicate that they are a single object's motion. So thank you, Tiamo. That is a nice point to bring up. You can keep in mind that you'll always have more than 1 line if there's a bounce. If your object does not bounce, it's going to be a single line, okay? Then the second person that had your hand up, NDZULAMISO. Sorry, I cannot pronounce your name. Please, can you ask your question?
Okay, I just wanted to ask, can you please send the question on the group after this lesson? This question paper.
Yes, the question was sent in the group, I believe 2 days ago, if I'm not mistaken. I sent a few of them. Were you in the group back then?
Nah, just joining now.
Okay, I'll resend them, it's fine.